processing. Classification by Fine 1996. What is it? What we are processing? What is a parallel processing? As we come to know, we can parallel some processing which is being run inside the CPU. What we are paralleling? The concept comes across. We want to increase the efficiency of the CPU or efficiency of the input processing and output processing so that we can make maximum utilizing CPU consumption or the computation of a CPU. As the hardware has been increased beyond the limits, we are having a more capacity to run more program on this one. But shall we support that one using the software implementation along with this one? Only hardware cannot implement all those things or do all those things. We need supporting system which comes from the methodology or the architecture which can make it run it in the parallel process. So we are having some classification in this class. Who has derived the classification? Michael Flynn, a scientist, he decided in 1966 the classification. He decided based on how the instruction and the data can move along with this one. So what is it do? Whether he has given all this information? No. It says earlier it was only instruction and data has been processed, parallelly processed. Based on that, he has decided to give 4 classification. But according to that one, still we can able to segregate these things. Even the technology has improvised in this one. What we are classifying, what we are doing, considering as a based requirement to classify it up in a parallel manner. That is, one thing is, your instruction is one of the things we can parallelly send to and fro. Another one is data we can send parallelly to and fro. From where to where we are doing this parallel processing. When you need a parallel processing, we come to know the instruction and data which should be enter inside should be a parallel manner. That is, I can send the instruction, I can send the data parallelly so that the processing can happen in a parallel manner. Now we can see how the instruction and data can parallel, and based on that classification can happen in this one. Now normally it's a single instruction we can go across in this one. It's an instruction. We need for the instruction some data. Who will send the instruction? Memory unit will send the instruction for you to send inside the processing unit. We can call it up as a PU. Here whatever latest state we call it up as a processing unit here. So the processing unit receive instructions from this one. Then instruction will be worked along with the data. Data also come from the memory and they will send back all this play back to the memory itself. So what it is, instruction has to come from, data has to come inside the processing unit. Parallelly they can work and the parallel processing can happen in this one. So how much data you can send across? You remember one thing, instruction always come from memory, it's a one-way data. Either instruction goes from here itself, but there is no need, unless it's going to be loaded back to the memory, it will go across. Otherwise, it's a single point of communication. But data need not be like that way. Data can be a two-way communication from the processor. It can go into the memory, and memory can come across in this one. So now we are having two set of units, which is going to be decide how many classification we can make across. One is your instruction, another one is the data. Right? Here, this is an instruction we put across. Then this we are putting across data. Right? Instruction is one thing which will allow the data to do whatever it want to do it up. Data is one thing we are doing operand on this one. Again, it's an instruction, then data. The process which is going to be work on this one, they send it across and the bus is called the instruction stream or the data stream. Stream in a sense, set of instruction goes across from one place to another place. The same thing applicable, data from one place to another place we can go across. These two are instruction. Now we can come across how much instruction we put across, how much data we can put across. Here it says, here instruction and everything. I can say it is whether it is a single instruction or a multiple one. Right? If I say single instruction and a single data, I can put it across in this one. How it is go across in this process. Now we will say, here we are having based on the single, multiple and everything. I started with a single instruction and single data. What it means. Right? Based on the Flynn, he said it could be a single instruction methodology. You can say uniprocessor is normally running a processor. So what happens here? I can get an instruction, I can work on a data which is very unique or only one set of data, one set of instruction. Either I put an add on a plus b, or I can load some instruction, or I can store some instruction. Any instruction comes across a single instruction, single data, it completely comes under uniprocessor. Now we are having it up as a single data. If there is a data pool or data available in this one, it is going to be a pool. Then I can say it gets into processing unit. Then at the same time, your instruction will be get inside that one. So it's a single instruction. I can call it a single instruction 1. Data is a data 1. So if that is happened, this is called your unique processor, single processing unit. It will run only one set of data on a one set of instruction. Now it is a very simple. Earlier it was like that way only. But once the technology has developed, the pattern has been gone across this one, there has been change happen in this one. What is the changes? How it has been reflected on the technology side. Now it is going to be not a single data, it is a single instruction. We are using it up as a multiple data. Am I right or not? Where we will use it up multiple data. Is it quite good? It's quite common. Yes. Iteration is one of the process where you can run the same set of instruction on different data. Okay, that is software side you say same set of instruction I run on a different data, right? Different data set. I can call it a data set or data you can put across. So I reduced I equal to int equal to a equal to 0. If it is if a less than or equal to 0, you can go it up a equal to b plus c. So if I say this is going to be happen in this one, I continuously do the iteration. So the single thing is my set of data is common, my set of instruction is very common, only one instruction, but data is going to be different data. Now what is it standing at? Where we are using it? It is going to be vector architecture or it is going to be array architecture. Vector architecture is same set of data, different types of data can be processed parallelly. If it is going to be only one instruction, this could be a different data. It is given an integer, it is going to be a character, anything. Same set of instruction run on using this thing and same parallel processing happen in this one. That is why it's a vector architecture. What about an array architecture? If the data type is same, it is going to be integer, it is going to be character, it is going to be anything, floating point, anything comes across. That type of array architecture will go across and do the work. So these two are very much example of single instruction multiple data. So we have seen SISD has been completed, SIMD has been completed. Then what is the remaining one? That is a very crucial one because we have completed only the single set instruction on a different data sets there. Now we are having it up in this one is multiple instruction on single data. Is it possible? Yes, it is possible. But it is a very crucial one. It is never run on your Earth side. It is always happen in the space shuttle. Practically, it is not a very much interested or very much in the parallel processing side. We normally go across in the space shuttle side. So it says multiple instruction on a single data set. How it is possible? It is a data set is going to be get inside. Whichever data you want, you can pick it out there. Then it is getting to the PU. That PU is called processing unit in this one. Then the same data set can be going to another PU. Right? The instruction can be come from different. So this is your instruction pool. So the instruction can come from in this one. So I am sending the same data to everybody. Then it happens instruction could be different from this one, not the same setup. So I can add multiplication or same set of data. It could happen in this one. But that is a higher level of application only happens in the space shuttle side. It is not going to happen in the normal side. So this multiple instruction or the single data set is one of the highest level of instruction. Our spatial side. Now we are entering in the last one. What is it and why we are we going to apply all those things? Yes, the classification here derived in this one is, it is going to be multiple instruction with multiple data set. So you can call it up as a, we have completed MI, SI, MI, MD. This is it. SMI, you can put it up this way, MI, MD. So multiple instruction with multiple data set. Then you need lot of energy and put across and say, this is possible in this one. Yes, that is the real crush of using a parallel processing. How we can go across using the multiple instruction with the multiple data set. That is, you can have normally we used to have a data pool that is relevant to this one. Data pool is available in this one. Then we can put across how many of this one. It is going to be a ID. This is going to be a PU. I can write it up this way. Right? I can have a different PUs. Processing unit. Real crunch of using the parallel processing come from this one. Whatever we have seen here, that is giving a small, you can little bits of some parallel processing. But when it comes across the real processing one, here we are having a processing unit, different set of processing unit. The same set of data go to different PU, right? Because I don't know whether that is going to be on the same set of instruction, right? That is a different PU. The same thing is going to be, I have an individual instruction unit which will supply the instruction to this one. So I have another instruction unit which can give different set of instruction for this one. Right? It seems to be there are parallel processing happen on instruction and the data sets. Is it possible? Yes, always it is possible. Where we are having all those things in this one. Here it's going to be how the processing will go across, right? This says it's a memory and everything. It's a normal thing. We are having data pool, PUs, different PUs are running across in this one. Then they are getting instruction from different unit. They are also doing different processing. Now everything is very clear. We are having SISD, SIMD, SISD, MISD, MIMD. Now what we are having it up is how these things will share the memory in this one. I can say this is a very unique one. No need to worry about how they share the memory. No need to worry about how they share the input processor. Everything is very simple. So we need not to worry about how these things will go across. But once there is a multiple calls has been comes across, or I can say multiple way of explaining comes across, I have to do the work here. What is it there? It is multiple data set. Shall I have to do? I have to share the memory in this one. Yes, I can share the memory in this one. How it is possible in this one? Memory is going to be here. We can say if I am having a different set of data, then there is no need to worry about all this one. Already our memory is going to be here. That has been divided into different blocks. So it is going to, the data can be fetched by the instruction sent into the PU. According to instruction, we can send it to the PU. So memory sharing started with the multiple data you can come across. As data is not going to be reside in the PU or the processing unit or CPU, you can call it up. Need not worry about how the sharing happen in this one. But when you go across multiple instructions, there the problem starts in this one. Where the problem starts. See, normally a processor is going to be, single processor unit is going to be run across using any set of instruction and the data set inside. They will produce a result here. Whatever the result may be, it can be an instruction, it could be a data. This is a result is going to be comes across in this one. Whatever it result may be, it could be a store, it could be a load, or it could be an addition, anything you can say it up there. So this is a processing unit. But here, multiple instruction comes across, we have to send multiple instruction in this one. Then it could be a single data. These multiple instruction which we are talking about should be reside in this one or should be fetched from that one, or I should have a sharing memory within the CPU so that I can fetch all the instruction, or it has to be fetched and put it inside the CPU before the whole instruction processing starts in this one. Data can be reached parallel, but instruction is an important factor we come across. So these MIMD, when you speak about the MIMD, there is a very much way of sharing the memory is going to come across. Multiprocessor, multi-core or multiple sharing memory, anything comes across. I can share the memory in a network manner, or I can share the memory or increase the memory using the cache, or I put across the small memory in the PU or the CPU so that they can share it up there. So sharing is going to create higher processing here. What the processing say? If I have a 3 or 4 processes running parallelly, I want to know what is the data set it is working on, what is the instruction it is working on, what is the status it is working on, which are the processor it is catching in within itself. So everything goes across when one processor, when you say it's a parallelly you are running it up the multiple instructions. So I have the set of status of all these things stored in this one. When something happens, the OS says we have to stop everything, they have to store all the status at the parallel level and do attend the OS in this one. So when you say multiple here or here anywhere else, whether it's a single data, whether it's a multiple data, you have to make sure this sharing should be proper. Interprocessing communication should be very much proper. One to another, one is getting inside, another has to stay apart from that one, so that the processing unit can work on only one single data. If it is going to be parallelly so many processes runs across, you have to make sure the processor should not get attention, or it should not catch a processor in this manner and keep it with itself so that everybody will be starving up. So when you go across these things, issues will be rises, and how the issues will be handled in the later stages we can go across. Thank you.